Hi, welcome to the GF channel. In today's episode, I'm going to modify those light bulbs which I installed the last time because I'm not a fan of how they work and they go out of sync sometimes. So the way they work is you power off and then on and they switch color. But sometimes they actually switch, one of them switches, one doesn't, and you get crappy color. So I'm going to modify them. I want to actually be able to control them by the fog lights. So when I turn on the fog lights like that, then I would like those to become yellowish or yellow. I'm going to actually even modify this light bulb to be a 3-color version because they charge more money for the 3-color version and it's only software. So I can do software. Okay, let's open this one up so we can see how can we modify this one. Okay, so there are 4 screws which need to be removed, and there seems to be some sort of silicone inside. Let's see how we are going to get this one out. This one is not even budging on that side. It is. Yeah, but it's glued. Let's see how we are going to push the whole thing out. So no sealant on the edges, but the whole PCB is actually in a sealant. I plan to do exactly the opposite when assembling. Actually leave the PCB alone and seal only the edges because I do not have such a glue to seal that I'll be able to disassemble afterwards after using it. Okay, let's see. Okay, so on the vise, just smacking it from the top and it started dropping off, but I'll need to unsolder either this one or this one, probably this one. I'll have to remove this silicone. Apparently it seems removable. Yeah, I'm going to probably break it and unsolder the wires because now this hits stop. Okay, there was actually no need for me to unsolder it. Well, there was, but in order to open it, this is actually movable. You can move this around, as you can see. So there was no need to unsolder so I can get more length. But in order for me to actually get it out, I need to unsolder and remove all of this. As you can see, it removes very cleanly. I don't know what that thing is. If you do know, let me know in the comments because I would like to grab some. I really like it. Okay, let's clean it up and go upstairs to do some debugging on the signals. Okay, while actually trying to disassemble this one, see this missing capacitor? Well, it's here, and well, I smacked it quite hard. Oops. Anyhow, I smacked it, so to compensate, I have quite a lot of those. I'm going to replace them, but interestingly enough, the LED still works, and if I turn off and on again, it still changes color. So this thing, it's either for bigger, let's say, like that. No, it still works. I thought it's for bigger impulses, but it's not. I don't know what's for, some filtering. I have new ones. I'm going to actually replace it, but it seems like it's an optional one because it works without it. Still, I'm going to replace it. Okay, let's debug the schematics right here. So you see, there are 2 sets of transistors right here, and this appears to be a microcontroller. So Now I am going to turn on 12 volts from here screen. Just measure that this is actually running. It's hard when I look on the camera, sorry. And we have not a good contact. Yeah, 12 volts. And now interestingly, if I measure right here, we see that we have voltage here. At the same time, if I measure on the other side, we have nothing. Now if I quickly come here and just turn on and off and on, we are swapping the LEDs with that. So currently if I go and check the top one that used to have high signal, it has nothing now, and instead, come on, and instead if I'm able to make a good contact with this, it's here. So it's as simple as that. We need to put high signal here for one LED and high signal here for the other LED, and either we need to cut here the wires or just remove this, which is the preferred way because it could be resoldered afterwards. And then we place this one on top, which fits perfectly. Come on, folks. This fits perfectly. So we are going to use it. Okay, let's remove this from here. Okay, quite sure this won't work ever again if I resolder it, but here it's clean, which is good. Now we go to voltage. Here we have it. And if we touch right here the middle pin, you can see we have VCC. We are going to grab this VCC and add it to the microcontroller here and grab ground from ground, and we should be good to go. And now there is nothing to control these, so if I touch the previous points, it's 0 here and 0 here, so everything is good. Let's solder. Okay, so I ended up using the power from here and sending it to the row pin because the power supplied from here for that microcontroller was not enough, and this was constantly rebooting. I've also added 2 wires for the 2 outputs. They are diagonally of each other. I'm going to make schematics later on, which is what. And I did a simple program that will just cycle through the colors. So if now I turn on the voltage, you can see first white light, then both lights for 5 seconds, and then we have yellow light for 5 seconds. Then everything goes off and it repeats. But that shows that everything is working. We can control everything, no problems there. So I need to do better wire management here and figure out how to do the PCB. Now I need to do the program and 1 voltage divider for the input of the fog lights. Let's go. Okay, so that's how it looks like, the final result. Of course not stock pretty, but it works. There's the new line coming in through the grommet. I'm going to have to put some silicone, of course, here. Then a zip tie here, which I need to remove because in order for this to fit the box, this needs to be removed, so it fits from one side. Either this one or this one needs to be removed. Since this is not yet cut, I can simply do that. Then that one goes through the diode, as in the schematics. This here is the diode, which is held by this cable so it's not loose, and then goes to pin number 2. And there is the pull-up resistor SMD from pin number 2 to pin number 3. That should do the job. Then pin number 4 is one LED color, and pin number A3 is the other LED color. This blue here is the ground, and here we have the power. That's pretty much it. That should cover it. So after everything is soldered and tight neat package, this shouldn't wobble or anything. Let's test if this still works. Okay, yellow light 24 watts, both lights 22 watts, and 24 again I believe was the white one. So yellow 24, 22 both, and about 24 for only white light. Okay, everything works. So from now on what I need to do is actually tweak the program to actually work properly when I have this input actually going to the car, so I'm sure it works on the car. Okay, let's do the prototype wiring. Now I have wired here the module still open, still being able to program it, because I want to make sure the program runs fine on the car. And the additional cable we get and we shove in here on this relay, which is the fog relay, and that's the pin of the coil which gets ground from the switch. Now we put back the relay, make sure we're not doing anything bad. This does not click. I'll have to probably do some tinkering around it so it clicks, but for now it's good. And now let's actually turn off the lights, and I'll actually turn off the torch as well. Okay, and now check this one out. I turn on the headlights. See the delay, how much faster the other one turns on. This is the stock one, which becomes yellow when you turn off and on again. So you can see the difference. That's why we actually need to flash the Arduino without a bootloader, so it's way faster. This is one thing we should do. Okay, now turn on the fog light. You can see now it's more yellowish. Turn off the fog light, it's back to being white. Turn on again, it's now very yellow. Turn off, white. Turn on again, start cycling. Yellowish, I call it amber. White, yellow, white, amber, white, yellow, white, and it keeps cycling. Now if I turn off the headlights and I turn on and off and then I turn on the power and then do 5 turnings of the headlights of the fog lights, sorry, we're going to change that thing. Okay, 1, 2, 3, 4, 5. It turns off, then shows white only, then turns off again. This means we are now only white. You can see no matter what I do, it doesn't change. That's what I left in the file only. You can configure before flashing lots of modes, which you can then on the car go and tweak yourself. So if I now again turn off the headlights, turn them on again, and do the 5 times, you can actually see now it goes white, amber, yellow. So this is the new sequence we're going to get. Let's see. That's the sequence. Okay, This is so you can change your settings on the fly. Very useful if you're going to actually yearly check, and they don't like on the yearly check that yellow light. So you should disable it before going and then re-enable it after going. Okay, prototype seems to be working. Let's now flash without the bootloader so I can close up the box. Okay, final prototype. Everything looks the same. I'm ready to actually remove those pins here. I've done all the programming, found few bugs, solved them, and I've optimized the launch time. So now, if I turn on the headlights, you're going to see how fast these actually turn. Very fast. I'm very happy. This is just by flashing the sketch without a bootloader. Okay, now it's time to actually put this thing in a box. Okay, here we have it. I have decided to unsolder from this side, not to touch that side here. I've used some heat wrap, heat shrink, but since I need to solder afterwards, I couldn't use by the end. So at that part, I'm going to use some of this electrical tape, wrap it nicely, and then I'm going to use this gasket head gasket silicone to actually make it watertight. Should be good enough from both ends. Should be good enough. Let's see. We are almost there. I was supposed to say that's the final result, but a problem appeared and we have to fix it now. So the problem actually appears if I use the coming home, the thing you can click at the top if you don't know about it. So if I double press unlock, and you can see the headlights start, but they start in yellow color. Why? That's not good. So let me open and close the door. I started actually debugging the issue. You can see here where the cable goes out of the relay, which I showed you we need to grab, and I'm measuring it towards ground to see what's on that line. So voltage, double unlock. This doesn't do anything, probably. Yes, have to push it a bit. It has 1.6 volts here, 1.6 volts. So this line is actually dirty. Let me again open and close the door, otherwise it's going to relock itself. 1.6 volts. This line is actually dirty. That's why this activates, because it is dirty. Why is it dirty? It's actually something quite simple. Let me turn off the torch. Something quite simple, which I underestimated. This is the front fog light relay, and we are tapping right here. And if you look at it closely, it's quite simple. It goes like that line, and through the switch when you have clicked on it, to ground. So you're just grabbing that ground when there is ground, when the switch is on. Sounds simple, right? Yeah, but the coil of the relay is also a wire, and on the other side of that wire there is also a wire that goes to E1 117. This is E3, E2, E1 117. It's here, and you can see it goes to 12 volts when the tail relay is activated, but it also goes to a lot of other light bulbs, a lot of them, and the light bulbs leak as well. So in the end we have leakage, ground leakage, coming towards the Arduino. So this line is no good. we need to actually do something else, not directly grab, or was it? Not directly grab this line, but use this line to actually go and fetch real ground to the Arduino. Okay, I'll dig a little bit more to see what I can find out. And so, finding ground on the inside of the fuse box under the bonnet is kind of quite hard, because the ground is the controlling signal, meaning everything is constantly powered on, and the ground comes at certain times to power on the relay. But there's one exception, only one. This relay right here, blower relay. This has constant ground, as you can see. And this one is for everything, full auto AC for RF turbo has it, the FS and FP full auto again has it. Here it is, same connection. The same goes for the manual. There's the relay with the connection, and that's manual for RF turbo, and same relay with the same connection for manual AC FPFS motor. So this relay is our key, and when we come here we can actually find it right there where it says cooling fan. That relay is this relay. And now let me turn on the multimeter and grab the other end. So the black one is towards ground, and this one is right here, this pin. This is the one we actually need. And as you can see, I have already prepared schematics that will solve all my issues. Now you can do that with that schematics which I'm going to supply, or just by using a simple relay. Only one relay is enough. But I don't like relays, they produce electrical noise, and also they are mechanical, so they are bound to fail at some point. So I prefer this. But the idea is the same. You can see, you grab the two legs of the initial relay we were going to use directly with this signal. Instead of using it directly, we tap into when the coil is going to actually energize. You can do the same with a relay, second relay that will activate when this one activates. Then we grab the ground from here, we grab this ground and we send it towards the signal we already have. I've already showed you. That seems to be working quite well. I'm going to now wrap up everything and show you the final result.
Okay, it's like the Japanese knew somebody's going to tap into their system, and they left a tiny little groove here so a cable can come out of here easily. See that groove right here? It's not done by me. It's stock. It's also on this side as well. So place the cable here and bend it to here. Then go around and maybe go around like that and come through here where there is a stock groove for cables to come out.
Now that's the final result. Here's the schematics right here, or if you're using relay, there's a spot here, fits perfectly. You can see the cables, how they come like so and like so, and the two relays, this one and this one, have clipped good with the clips, so they're not going anywhere, which is always good. The only problem I actually have is the cable. I had to shorten it here due to the new stuff, and now it's too stressed. I don't like it. It's too stressed. That's the only thing I don't like, but cable can be extended if needed. This hood thing, this battery thing is not good. Okay, so now with everything done, let me show you how it looks like. Turn on headlights, and now when I turn on the fog light, it becomes amber. I turn off, then turn on again, yellow. Then we can switch them to constant, 1, 2, 3, 4, 5, and white only. This is it, white only. Now when I turn on the bottom, you can see not changing. This is when I go to the yearly inspection, which is in 3 days. So I can then switch back 5 times after the yearly inspection. White, amber, yellow. Good. And now it works. And finally, the thing that I noticed, double unlock, and you can see it's white. So this problem got solved because there's no longer dirty ground. Okay, that's all. Hit subscribe. I will post more videos soon. Bye bye. It's like a gum. See? Like a gum. That's very good.